This is a question from algorithms. What is the running time complexity of the following recursive function? We have a function named int CompuFun which takes an integer argument. If it is n is less than or equal to 2, then it returns. Else, we are recursively computing the value of CompuFun floor of square root of n plus n. So this is the recursive function. So let's try to write the recurrence relation. For the time being, let's ignore the floor value. It does not have much impact when we are calculating the time complexity. So we can write the recurrence relation as T of n is equal to T of root n plus 1, where n is greater than or equal to 2. This n is ignored because only this parameter is causing the recursive function's computation. And based on the value of n, we are just adding this value. So this is like a constant addition only. So the recurrence part is only T of root n. So let's calculate. So we can write it as T of n is equal to T of n to the power 1 by 2 plus a constant 1. Now assume n is equal to 2 to the power m. Then we can write it as T of 2 to the power m is equal to T of 2 to the power m by 2 plus 1. Now assuming that T of 2 to the power m is equal to S of k, we can write S of k is equal to S of k by 2 plus 1 can be replaced by a constant c. Look at this particular recurrence relation. This recurrence relation represents the recurrence relation for binary search. So without using any master's theorem or any substitution method, we can outrightly solve this. So the time complexity for this is theta of log k. This is the answer. Now this is in terms of k. K has to be replaced with this, that is 2 power m. So 2 power m has to be replaced with n. So we can write this finally as theta of log of k is 2 power m, then 2 power m is n. Finally the question is asked in terms of n. So replacing this with n, we will get k is replaced to n. We can write it as log of log n. So the correct answer is theta of log n. Option D is the correct answer here.